All right, welcome back. Long time no see. We had a few days off because we took that Unit 3, Sections 1 through 3 test, but now we're back in it. Going to hit you with Unit 3, Lesson 5. Now, some of y'all are saying, well, what about Lesson 4? We'll come back to that. The people who made this order didn't do a good job, in my opinion, so we're jumping 4 for now and going to 5. 5 is going to talk about parallel lines and triangles. More importantly, though, check this out. The Triangle Angle Sum Theorem. Literally the second most important thing I'm teaching all year. So after today, I will have taught the second, the third, and the fourth most important things I'm going to teach all year. Still haven't got to the first most important thing. That's coming up in the spring. All right, so let's just jump right in and start learning. Well, before I jump in, some people like to know where we're going before we jump in. Well, what's going to happen today is I'm going to give you a way to find missing angles in a triangle. The triangle is the most important polygon in geometry. That's what makes this theorem you're learning today very important, because we're going to learn that all triangles have to add up to 180 degrees, and their angles do at least. And so now when you're done, you'll be able to find missing angles. If you know 2 of them or have enough information to get 2 of the angles, we can find that third missing one using what we're going to learn today. So let's jump in and do it. All right. So like I said, Theorem 311, again, the numbers on these theorem are not important. It just tells you basically this is the 11th theorem in Unit 3. And it's the Triangle Angle Sum Theorem. And what it says, the sum of the angles of any, and notice how any is in all caps, of any triangle is 180. And there's that 180 number again. It always pops up in geometry. It's the most important number. So the 3 angles of a triangle always add up to 180, whether they have numbers in them, algebra expressions in them, either way, they always add up to 180. Is that just true in this chapter, Mr. Megan? No, it's true forever. Matter of fact, if you traveled to Japan or Europe or somewhere, their triangles, the angles add up to 180. I promise you, this is kind of a universal truth. All right, and here it is written out for you. The measure of angle A plus the measure of angle B plus the measure of angle C always adds up to 180. Whether it's an acute triangle, an obtuse triangle, a right triangle, it doesn't matter. 180. All right, moving on. We got a little soccer practice drill. We're in girls soccer season here at Charlestown. I don't know about boys soccer season, but girls soccer season I know is going on. It looks like we got 3 girls and a guy here. I guess Charlie could be a boy or a girl. But they're kicking a soccer ball around, and hopefully that gets your attention because it's soccer. Maybe you're interested in soccer. A couple of these players, they're really into geometry, and they're literally keeping track of what angle they're kicking the ball at. I don't know if y'all couldn't see that, but I just did a kicking motion with my foot. It was off screen, so we got this girl named Amy, and she apparently is one of the ones who does like geometry, and she's noticing that when she receives the ball from this Barb lady and then kicks it, she's kicking it to Barb, and when she receives it from Debbie, it's at a 20-degree angle. So Amy kicks it down here to this Barb woman, and Barb does not seem to care as much about geometry or angles, so she just kicks it all willy-nilly, as we say in the hood. She kicks it all willy-nilly over here to Charlie and doesn't really keep track of what angle she kicked it at in degrees, so we'll just call that Z. Charlie, being more interested in geometry, when he receives the ball from Barb, he kicks it at a 61-degree angle up to Debbie, and then Debbie, again, does not care so much about geometry and kicks the ball just in any old angle over here back to Amy. So her angle is X. So we got some angles we don't know, we got some angles we do know, but the important thing is we got 2 triangles. And what I just told you on the previous screen is no matter what, those triangles' angles have to add up to 180. So I'm just going to put a big fat 180 in here. So that one's got to be 180, and then this one's also a triangle, so that one's got to be 180 degrees. All right. Now some of y'all are saying, but Mr. Metcalfe, you're missing 2 down here. That's going to be tough. We got it. We'll get to it in just a minute. I will say Ethel's been a little temperamental today. It's a Monday, and it's a rainy Monday. Got the parade tonight. It's homecoming week. I always love homecoming week. Get to wear something. Today was class day. I couldn't find my sophomore class shirt, so I just wore my Charlestown Pride shirt. They said that was okay. So we got that, and tomorrow's pajama day. Everybody loves pajama day for some reason, so I'll be wearing pajamas tomorrow. Oh, I don't know if I'm doing a video tomorrow. Maybe I will, just so I got my pajamas on. Okay, that'll be fun. or scary, disconcerting. Ooh, that's a good word, disconcerting. All right, so back to this. So we got to find out X, Y, and Z's angle. Well, here's X, that's Debbie's angle. Z is this Barb woman's angle, and then Y is this one that's not really associated with a particular player. It's just one that's created by the balls crossing paths there. So X, we'll just go alphabetical order. X, we do know the other 2 angles, so you should try, even though I haven't really processed one of these problems yet, you should try to figure out what you think angle X is, and I'll pretend like you did that. You could hit pause right now, and then we'll come back and say, hey, what'd you get? And since you haven't done one, Mr. Metcalfe, so I didn't try it, I'm going to wait for you to explain it. I'll do that. So in this triangle that has to add up to 180, we got a 20 and a 78. So what's the missing one that will complete the 180? Well, I add the 2 I have, the 20 and the 78, and I always recommend you do this using your brain power during the lesson, and on a test you use your calculator. But right now when we're in a lesson, it's okay to make some mistakes as long as you fix them and everything's good. So I'm going to do this, pencil paper style. 0 and 8 is 8, of course, and 2 and 7 is 9. So I've got, between these 2 angles, I've already got 98 degrees. What would this Debbie's angle be to complete the 180? Well, I would take 180, because that's how much I need. I would subtract off what I already got, 98. And I got some situation here, you can't subtract 8 from 0, so I'm going to do what we called in the olden days, borrow. So this 0 now becomes a 10, and this 8 represents 80, so it now becomes a 7, which is representing 70. So now I can do this problem. So I got 10 take away 8 would leave me with 2, and then I've got 17 take away 9, which would leave me with 8. So if you had 82 degrees, you got it correct. So we're going to put an 82 here, and as with all geometry problems, this may help me later and it may not. Now that I know X is 82, I'm going to put an 82 over here. All right, that could help me later on. It might, maybe it won't, but I'm going to put it there just in case. So now we move to Y. All right, Y is the second angle. Some of y'all saying, Mr. Metcalfe, we can't do that little thing with the 180 because you're missing Y and Z. You're right. So we have to do something else. But I'm hoping most of you, like a red flag or light went off in your head when you saw this picture. You got this perfect X here in part of our diagram, and when I've kind of emphasized whenever that happens, the 4th most important thing I'm teaching you all year happens, and that's vertical angles. All right, you got a perfect X, and we learned that the angles opposite each other in that perfect X are the same because of vertical angles. So if he's 78, then Y is also 78. So I'm going to put a 78 there. And over here on my answer form, I'm going to put 78. So I got 2 down, and now that sets me up for this Barb lady's missing angle Z, all right? Because now I've got 2 of the other ones, so she just needs to be whatever's going to complete the 180, right? So I've got 61 and 78. I'm going to add those together. And 1 and 8, of course, makes 9. 6 and 7 makes 13. So I got 139 degrees just between these 2 guys. They take care of the bulk of it already. So what would Z have to be to complete the 180? Well, you take 180, you subtract off the 139 that you already got, and that'll tell you what Z is going to be. So once again, I need to borrow because you can't take 9 from nothing. So that's going to turn into a 10. The 80 then turns into a 70. Or actually 170. So 10 minus 9 is 1. and 7 minus 3 is 4, and of course 1 minus 1 is 0. So the missing angle is 41 degrees. And if you add those three up, I promise you, you will get 180. All right? So any questions on that? That's the basic premise of what we're learning today. If you got algebra or know two of the angles, you can find that missing one. Just putting into play this concept of triangles always adding up to 180. All right? So moving on. Okay, now all they've done is they've taken two triangles and mashed them together, which kind of creates not just two triangles, but three. You've got the one up here kind of on the upper left, this one down here on the bottom right, and then the overall triangle. You can't forget that. That's a triangle too. So, Mr. Metcalfe, you're saying all three of those will add up to 180? How's that even possible? Well, remember, the angles of a triangle are just it's three corners. Like if I'm talking about this big angle, I wouldn't talk about this angle 1 or this angle 57 because he's not one of the corner angles for the big triangle. So, yeah, so they still will. Each individual, 180, 180, and then overall, 180. That is going to happen. All right, so let's take a look at angle 1. Now, angle 1 is in this triangle here, and he's got two missing angles because you're missing angle 3 as well. So you're not going to be able to do the new trick, but you're going to do, man, see, these things are so important because now what's popping up that you have to know to do this problem is the third most important thing I'm teaching this whole year, and that's linear pairs. Those are not ever going to go away. You see angle 1 is a linear pair with this 57. And so linear pairs always add up to 180. Remember the big yellow circle from several lessons back? Well, half of a circle would be 180 degrees. So if this guy's 57, what would angle 1 have to be? So you do this. You take your 180, you subtract off that, and again, to do this, you're going to have to borrow, so we'll make that a 10, make the 8 turn into a 7. 10 minus 7 is 3. 7 minus 5 is 2. 123. So angle 1 is 123, and that's from what we learned a long time ago about linear pairs. That has nothing to do with triangles, but again, the assumption is, since that concept is so important, it's going to be here for the rest of the school year. You just got to know linear pairs always add up to 180. All right? So there's angle 1, 123. So now we're ready. We can get angle 3 because we got the other two, but we're going to go in numerical order, and we're going to jump down here and get angle 2. So in this triangle, also has to add up to 180. You've got two of the angles so far. You got the 71 and the 57. So we'll add those together. And again, you should be doing this at home. You should have hit pause and you're working this out on your own and seeing if you're getting it right. So when I add those together, 1 and 7 is 8, 7 and 5 is 12. So you got 128 degrees already without the 2. All right. So what will 2 need to be to complete the 180? Well, I think most of y'all know the procedure now. You take 180, you subtract off what we got already, which is the 128. And again, try to refrain from grabbing the calculator during the lesson and on your assignments. You should be using your brain and pencil and paper on that. But on the test, yes, use the calculator. But right now, let's use our brain. I'm going to turn that 0 into a 10, which means I had to borrow from the 8. So he's now a 7. 10 minus 8 is 2. 7 minus 2 is 5. 1 minus 1 is nothing. So the missing piece, 52 degrees. Ta-da! Okay, that leaves angle 3. Now, everybody's been jumping in today and saying, okay, well, we've got the other two, so let's just use this triangle. And that probably would be the easiest way. But as I've been telling everybody, the overall triangle has to add up to 180 as well. So there is a second way to swing this dead cat if you wanted to. It's a little more involved, so you're probably going to just use this triangle. But you could say, hey, the overall triangle has a 52 down here, and then here at K, the 28 and the 71, that would make 99. Woo! If you wanted to use that. and then 3. So that's one way you can do it. You can do the 99, woo, and the 52, and him make 180. Or most people are going to use this one because this triangle's got to be 180 as well. So you're going to use the 123 and the 28. And so I add those together, and I would get 3 and 8 make 11, carry the 1. 1, 2, and 2 make 5, and 151. So these two guys are 151 together. So what would 3 have to be to complete that 180? Well, here's what you do. You take your 180 and you subtract off the 151. Again, you need to borrow, so he turns into a 10. That makes the 8 drop to a 7. 10 minus 1 is 9. 7 minus 5 is 2. 1 minus 1 is nothing. So angle 3 is 29 degrees. And if you want to go ahead and try that same problem with missing angle 3, 52, and 99, woo, you can. I promise you, you'll get 29 as well. All right, any questions on that? We're moving on. And if you need to, of course, hit pause whenever. Oh, go on to the next screen first. I got these out of order somehow, and I've never bothered trying to fix it, so we're just going to follow those directions. And here's a new concept. So I'm going to step to the side. You're going to hit pause and copy all this juicy information because this is a brand new concept going on here. What I've done is I've drawn a triangle, and I on purpose, or intentionally as we say, extended one of the sides, which has created an exterior angle. Exterior, again, a fancy word, means outside. So this angle is literally outside the triangle. Obviously, the 3 angles on the inside are interior angles, not a big deal, but here comes the new concept. 2 of those interior angles are what we call remote interior angles. Now, remote, about the only time you ever hear that word used is for your remote control for your TV. You hear it there. Those you are into those, now I hear the kids calling them RC cars or RC planes or whatever. Remote control cars where you got the little thing and your car's zipping around in your neighbor's driveway and he's upset and stuff. Or the RC planes, you fly if you're, I got a park near my house where a lot of old dudes have those things and they're flying these little toy planes up in the air. So you might get the idea that the word remote has something to do with controller, but it doesn't. It's just telling you what's being controlled, because the word remote doesn't have anything to do with controllers. The word remote means far away. Like you sometimes, like in that Tom Hanks movie where Castaway, he's on a remote island. That means it's an island that's far away from everything else. That's why people couldn't find him for a long time. Remote doesn't mean controller. It means far away. So, your remote control for your TV means you can control the TV from far away. I'm old. When I was a kid, we had to walk over the TV and turn the dial to change the channel. And then when I got in high school, we got the little, we called it a clicker box. We just went click, 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 and do the channels that way. But yeah, when I was, in elementary school, yeah, you walked over the TV and, yeah, okay. So, what does it mean? Remote interior. You're making a big deal about remote means far away. What are these 2 angles far away from? All right. Well, they're called the remote interior angles because they're the inside angles that are far away from this exterior angle. All right. So I made an exterior angle over here. This angle right here would be a close interior angle. He's close to the exterior angle, but I don't care about that. I care about the 2 that are far away from him. This one up here and this one down here. Those are remote interior angles. They're far away from the exterior angle. And why do we care? Well, they have a cool relationship with each other. So the exterior angle theorem says the measure of an exterior angle, so that guy right there, of a triangle is equal to the sum of its 2 remote interior angles. So these 2 guys added together will equal the exterior angle, all right? And I have that demonstrated here in this situation where the exterior angle is angle 1, see the measure of angle 1, is equal to the measure of angle A plus the measure of angle B. So the 2 that are far away from him, he's equal to them added together, All right, very important new concept. Probably has not been introduced to you at any time before today. So just make sure you got it established in your head. So I'm going to say it again. The angle on the outside is equal to the two inside angles that are far away from him added together. All right, so brand new concept. Hope you got it down. And now we're going to go back to the previous screen and do this little easy problem that kind of demonstrates it. So you see I've drawn a triangle. I extended one of the sides, creating this exterior angle, which is labeled X. And you can see the close angle, don't care anything about him, no markings on him or anything, but I do have markings on the two remote interior angles, all right? So one of the remote interior angles is 46, the other one is a red box, which I think everybody knows at this point. If you don't, you've really not been watching the videos. Red box means 90 degrees, all right? So he would be the sum of these two guys, so I think everybody knows you would take 46, simply add it to 90, and you would get 136. So this exterior angle is 136. Ba-da! Now, pause for a second because you're about to get confused here in a minute, because I'm going to click to the next slide that we haven't done, and you're going to think, Mr. Metcalfe, why are you wasting your time teaching geometry? You should be teaching art with this beautiful drawing you just made. Check this out. Behold, yoga woman. Yeah. So this is a woman doing yoga. Let's see if I can imitate what she's doing. She's kind of doing like this, I think. Yeah, something like that. And this is her hair falling down. It's not a skillet handle. Somebody said skillet handle earlier today. Somebody says, why is there a magnifying glass there? No, that's yoga woman. And you don't need to draw her. What we care about is that her legs and the ground make some angles that do what we try to demonstrate here. So her I guess that's her right leg and the ground make an exterior angle of 2x minus 15. Her left leg and the ground make an interior angle of 50. And then where her two legs come together make an angle of x. So that perfectly fits the concept I just presented, in that he's an exterior angle. These are the two remote interior angles. So you should know what to do. I'm going to pretend like you're pausing and you're doing that right now. And welcome back. What did you do to solve this? You should have set up some kind of equation. And the equation you should have set up was the exterior angle, 2x minus 15, is equal to the sum, as you all know means add, of the two remote interior. So these are the far away ones, x and 50. So x plus 50. And that sets us up with a nice Algebra 1 school bully situation. We got two x's on the left, ghost 1x on the right. School bully always picks on the smaller one, so he's going to mess with this ghost 1x by being minus x and minus x. That cancels out. The 2x, when you take away a ghost 1 from it, turns into a ghost 1x, minus 15. And that equals 50. And to get rid of the minus 15, of course, I would add 15 to both sides. And that x, which is the first part of the problem, would be x equals 50 plus 15. That's what, 65? So the x part of the answer is 65, but now they want the exterior angle, all right? Now there's a couple ways to swing this dead cat, because now that you know x is 65, you can put a 65 here, and you can put a 65 here. Now, most of my students today have been going after this right here. They say, okay, that's the exterior angle we want. I got the x now, I'm ready to go. So they did 2 times 65, which I think is $1.30. Take away the 15, gives me 115. So there's a pretty good answer. You look at the diagram, it looks obviously bigger than 90, so then 115 makes sense. Or you could say, hey, the exterior angle is literally the sum of these two, and I know both of these two, so if I add them together, 65 and 50, what do I get? Bam, you get 115. So now, with confidence, you're saying that exterior angle is 115. Either way I swing it, I get 115. Awesome. So there it takes care of 6. Oh my goodness, I don't know if y'all can see that. Oh, it's probably cut off on your screen, but that was screen number 6 out of 9 total. So we're almost done. And I got a little special treat for you on this next screen. Boom! It's a skip screen. Check that out, man. So we're just going to move on to screen 8. So we are almost done. Screen 8, you hit pause right here. I'm going to pretend like you did and copy this down. And now I'm going to process it. We've got a couple of corollaries of the triangle angle sum theorem. And again, corollaries, that's when somebody really smart thinks up a theorem or proves a theorem. And so this amazing knowledge is now had. And then either the same person or another person comes along and looks at that theorem and says, you know what? Now that we know that's true, these other things are true as well. They're side effects of a theorem. Now, whenever we hear the word side effect, we think of something bad. I mean, it doesn't have to be bad. I mean, usually, there's you take some medicine for your high cholesterol or whatever, and then they say the side effects include nausea, vomiting, diarrhea, stuff like that. We always think of bad stuff, but side effects don't have to be bad. I mean, I haven't seen it yet, but it'd be cool if like you had some aspirin or something, and they said the side effects is ability to see through walls or something like that. So side effects don't have to be bad. They get a bad rap because they usually are bad, but in geometry class, side effects are good. Corollaries are good. They're helpful, usually helpful. In the first one, we call it 3.1, it says the acute angles of a right triangle are complementary. All right, and that one just kind of makes sense. Now that you know that a triangle has to add up to 180, a right triangle always has one right angle in it. So there's 90 of those 180 degrees right there. So this is just saying, and you're going to say, well, that's common sense, Mr. Metcalfe. It's saying the two acute angles that are left over, they have to be complementary. And as you all hopefully remember, means add up to 90. So yeah, if this guy's 90 and the whole thing's 180, then these two guys added together must make 90. So common sense or corollary, however you want to look at it. The second one says, we call it corollary 3.2, there can be at most one right or obtuse angle in a triangle. So think about that for a moment. A triangle now, you've learned it has to add up to 180. If you tried to have two right angles in your triangle, that would be 90 and 90, which there's 180 right there, which would leave the third angle to have to be a 0 degree angle, and that's impossible. We don't have 0 degree angles, so you can't have two right angles in a triangle. So there's that. And then obtuse, as you know, is even bigger than 90. So if two 90s won't work in a triangle, then two things bigger than a 90 won't work either. So, and somebody saying, could you have one right and one obtuse? No, because literally, again, the right angle would be 90 and the obtuse would have to be more than 90. So when you put them together, that's already more than 180. So yeah, you can only have one right or one obtuse, and the other two have to be acute. All right. So, and that takes us to the last screen of the lesson. We got a nice yellow rectangle with several triangles embedded inside of it. Some of the angles are known, some of the angles are not known. Take a few seconds and draw it. We're going to find 4 of the missing angles here, 1, 2, 3, and 4. And again, each one of these triangles has to add up to 180. Its angles do at least. So use that to help you. Use other things about boxes. Boxes mean 90. So situation up here. Yeah, 2 of these guys in a box or whatever. So you know what they got to add up to. All right, but let's go look at number 1. We'll pretend like you paused it and you tried all 4 of these to figure them out. And now you're hitting play again to see if you got them right. So let's look at angle 1. He's right here. He's part of this probably the smallest triangle up here, over here on the left, which has to add up to 180. I've got one of his angles is 52 and the other one's a red box, which I think we all know is 90. So I'd take the 52 and the 90, I'd add them together, and I'd get 2 and 5 and 9, it'd be 14. So I got 142 degrees so far. I just now need to get the rest of it. So I take 180, because that's what it's got to add up to. I subtract off what I've already got, the 142, and just to speed things up a little bit, I'm going to just go ahead and tell you that would be 38 degrees. All right, so I'm going to go ahead and put a 38 degree up here, because maybe that'll help me later on, maybe not. But it's 38, so I'm going to put it up there. I have a feeling it is going to help me with angle 4 later on. I think some of y'all are saying, well, I already know what angle 4 is going to be. Boom. So, all right, moving on to angle 2, though. So angle 2 is part of this bigger triangle, and this bigger triangle has a box in one corner, a 38 in the other corner, and then of course angle 2 is what we're trying to find in the third corner. So again, the process is still the same. You add the two you know. You know the 38, you know the red box is 90, so add those together, 38 and 90, and you're going to get a 8, and a 3 and a 9 is going to give you a 128. So you got 128, you need 180. So you just subtract off the 128 from the 180. And again, to save time, I'm going to do that. That's going to be 52. So angle 2 is 52 degrees. So I'll put it over here in my answer area, put it over here in the picture, because I know it's correct. And that may help me out with angle 3. Matter of fact, it sure does. Angle 3, oh my goodness, I don't know any of the angles of this triangle. I mean, there's a good probability that this one down here, yeah, mathematically it would be 90 as well, because he's got a box over here and it's a linear pair, so that means they got to add 180. The only way to do that would be with another 90. So he's 90, but I still don't know 4 and I don't know 3, so I can't really use that 180 thing. But I'm going to use this red box. Red box means 90. I mean, it just does. So if the 2 part of the red box is 52, what would the 3 part be to complete the 90? Well, I just come over here and I say, okay, I need 90. I've already got 52, so let's subtract off that. And again, that would be 38. And we are getting some of the same numbers over and over again, aren't we? That's our second 38. And then there's a 52. I'm going to go ahead and put a 38 up here now. Now, there's a couple of ways to get angle 4, and this would be the last question of the lesson. And there's a couple of ways you could do this. You could say, Mr. Metcalfe, well, actually, technically, there is not a red box up in this corner, and there's not, well, I guess I think I could come up with a way to prove that that's a 90-degree angle up in that corner, but I think I'll just go ahead and use the 180 thing instead, because that's what we're learning today. All triangles are 180. I showed you why this has to be a 90, because you got a straight line here, and if that's a 90, this is got to be a 90 to make that linear pair 180, right? So that's 90. We just proved that that's 38. So what's 4 to complete the 180 for this triangle? Well, I'm going to add 90 to 38. Some of you already probably know the answer, because there's kind of a pattern going on here. 0 and 8 is 8. 9 and 3 is 12. So I got 128. I need 180. So I take 180, subtract off the 128 I already have, and voila, as they say in the French hood, it's 52. All right. Any questions? Man, we got one more lesson coming up before the fall break. And just so you know, on fall break, Miss Cook was so nice. She said, hey, we teachers and students working hard this first quarter. She said, go easy on them over this fall break. So I'm going to go pretty easy on you. There will be like 2 assignments. I think for the first week, I'll do a kind of a review assignment for this lesson. And then the second week, I'll do a review assignment for the lesson we're going to do on Wednesday and Thursday. And I think that's about it. So, but look on Google Classroom, it'll all be spelled out. And you do need to be checking Google Classroom, because I put important messages that I can tell some of you are not reading based on the emails you send me. You're asking me questions that are definitely answered in the Google Classroom stream. So, hey, save yourself a little time, me a little time if you just read that, and save you from typing an email asking me something that's already answered on Google Classroom. But hey, no worries, man. We're getting through this, one quarter down, and we are doing pretty good so far. My in-school people are doing great. My online people, the ones who are logging in, doing what they're supposed to, they're doing great. Some of y'all not checking those videos, not doing those assignments, not even taking the test. Some of you not taking the test. So again, make sure you're doing that and get that credit for this first semester. All right, talk to you soon. Bye.